Hello, I'm Angie and I'd like to present my findings on Lab 1 focusing on charge tapes. The objective of this lab was to estimate the charge on a piece of tape. To achieve this, we constructed a physical model to examine and observe interactions between pieces of tape, between tapes and different objects, including statistically charged objects. The experiment aimed to reinforce our understanding of electric field, electric force, and polarization, aligning with topics covered in class. Upon initial calculations, the tape's charge was determined to be positive, indicating a deficit of electrons. The physics principles applied in this experiment included Coulomb's law, basic force principles, conservation of charge law, Newton's second law, and the properties of particle charges. The quantified charge on the tape was found to be 7.04 times 10 to the negative 9 coulombs. Key measurements included the length of the tape, floating distance, and calculations involving gravity, force, and electric force. We also determined the amount of deficient electrons, the number of atoms, and the ratio of electrons to atoms. So, looking at our data measurements, our tape characteristics were distance, like we said, which was 0.015 meters. The width was 0.019 meters. The mass was 0.000202 kilograms. And the length was 0.202 meters. So the force of gravity, so we took mass and multiplied that by gravitational force. It was negative 1.9 e to the negative 3 newtons. And the electric force was 1.98 times 10 to the negative 3 newtons. And this makes sense because gravitational and electric force are equal and opposite to each other. The charge on the tape was 7.04 times 10 to the negative 9 coulombs. The amount of deficient electrons was negative 4.4 times to the 10th power. And the number of atoms was 3.84 times 10 to the 17th. And the ratio of electrons to number of atoms was 1.15 times 10 to the negative 7 electrons per atom. In addressing specific lab questions, we considered the interaction between a positively charged tape and a negatively charged plastic pen, predicting attractions due to opposite charges. So for a negatively charged tape, we anticipated repulsion when interacting with a negatively charged pen and attraction to a neutral pen, thanks to polarization. So observations in this experiment confirmed the expected repulsion between two negatively charged tapes. This is because like charges repel each other, and attraction between the tape and neutral objects, because and then validating the positive charge on the tape. So in conclusion, the U-tape is positively charged with a deficient amount of electrons. So using our code, we looked at constants, and we found that the constants employed in initial computations included the determination of the force of gravity and electrical force, the latter being equivalent and opposite to the gravitational force in our specific scenario. These are just certain codes because this presentation also included a code demonstration outlining the computational model, including calculations for electric and gravitational forces. So the visual representation of the model aligns with the theoretical expectation, further supporting our findings. Looking at the tape charge method and functions of E-field, so the procedures were formulated to compute the charge on a tape and determine the electric field. Utilizing these two methods facilitated the computation of the required values for the lab, ultimately presenting the results on the console. And in this context, visual objects were instantiated, comprising two spheres symbolizing the two pieces of tape, while the two arrows depict the gravitational and electric forces exerted on the uppermost tape. And this is the result of our code. So in conclusion, the experiment successfully estimated the charge on the tape, validated through calculations, observations, and a computational model. Thank you for your attention.